I transitioned from a shit-kicking cowboy of sorts, which is what people think about people who have a degree in range science, the ones who don't think it's about ovens. I transitioned from that point, and really the whole time I was interested in considerably more than raising red meat for the populace. I never focused on the animal side of the story. I was always focused on plant community ecology. And that, in fact, when I was working on my master's, and especially when I was working on my PhD, that's when I began studying climate change, mostly paleoclimate change. Why was there this sudden eruption of ponderosa pine in the about 1920 in the southwestern United States? Why was that? So I got to looking at that and matching up large-scale plant ecology patterns, plant community patterns, with paleoclimatic factors. And that came heavily into play, as I indicated, when I was working on my postdoctoral research on Cumberland Island. It's all about the precipitation, or at least it seemed to be. I became interested in the linkage between climate factors, especially in the past, and what's going on with plant communities right now today. So I began digging into the historical precipitation and temperature records, which in this country go back many, many decades. And so that played an important role in my postdoctoral research at the University of Georgia as well. And so I just kept studying climate change. And then I remember one of my first slides I had created for teaching at Texas A&M University was a cover shot from, I think, Time magazine that showed Yellowstone on fire due to the monster fire in 1988, summer of 1988 there. And that obviously was affected by climate change, although nobody was studying climate change closely enough to make that link at the time. So it was relatively early on in my academic career that I was focusing on climate change without really understanding that there was this burgeoning discipline known as climate science. It really was struggling to find its way at that point. So that by the time I got to my tenure track position on May 1st, 1989 at the University of Arizona, I had already been studying climate change and historically important climatic events in the past and how they influence plant communities. So it wasn't a big deal when I got to the University of Arizona, and my research and that of my graduate students and postdocs and undergraduate techs was influenced by and was directly studying climate change. One of my early PhD students did one of the first, I think it was among the 3 first rainout shelter experiments. And what we did was identify some relatively large areas and put rainout shelters over the top, and then apply various treatments underneath that big rainout shelter. We used chain link fence panels, big chain link fence panels, to make this above ground tent. It started about 4 feet off the ground so the air movement can go underneath, and so that we could go underneath and add precipitation treatments of various kinds to these relatively large plots in the ground. We separated the plots from the existing ground by digging trenches all the way around these plots and putting plastic down in the ground to separate them. It was really quite a monumental effort. We were interested in what kinds of factors influence the relationship between oak seedlings and the germination of those seedlings and the native grasses around them. That was early on in my research at the University of Arizona, and ultimately led to a book published by the University of Arizona Press with that same graduate student, the two of us editing. That book came out in 2003, So we were working on it throughout 2002, soliciting people to write the chapters, putting together those chapters in some sort of meaningful order, interacting with the chapter authors to make sure that there were links between the chapters. And that led to the publication of this book on climate change in 2003. So that book that I worked on with this graduate student of mine came to be known as Changing Precipitation Regimes and Terrestrial Ecosystems, a North American Perspective. Yes, I know you can read it as well as I can. It was edited by my PhD student, Jake Weltzine, and I, and it had chapters including some introductory stuff, and then the interface between precipitation and vegetation, the importance of soils in arid and semi-arid environments. So we're interested in soils, in soil-plant relations, responses of woody plants to heterogeneity of soil water in arid and semi-arid environments. So again, soil, water, plant interactions were key here. The importance of precipitation, seasonality in controlling vegetation distribution. And this chapter was contributed by a guy named Ron Nielsen, who at the time was the renowned modeler, among the best known modelers in the world, for what future climates were going to look like, and as a result, what future vegetation patterns would look like. Approaches and techniques of rainfall manipulation. So we tracked down everybody who was doing the kind of work that Jake and I were doing with rainout shelters, altering the precipitation. We tracked down the other people who were doing research on that as well, and had them write chapters. Ecological consequences of drought and grazing on grasslands of the northern Great Plains, and rainfall timing, soil moisture dynamics, plant responses, response of eastern deciduous forest to precipitation change, and so on. And Jake Weltzine and Jake went on to become a well-known professor and first director of the National Phenology Network of the United States. Another student who I advised is currently the director of the National Phenology Network. In any event, so I worked with these people who went on to do good things, and that book was, in editing that book and reading through all the chapters, it was then that I came to the conclusion that we're done.